Take apart an old computer, a TV remote, a game console, or even a washing machine, and chances are you'll find the same thing inside, a flat green board covered with tiny electronic components and thin copper pathways. It's so common that many people assume circuit boards have always been green. But here's the surprising part. They don't actually have to be. Modern circuit boards can be blue, black, red, white, purple, or even transparent. So why did green become the color we associate with electronics in the first place? The answer isn't because green works better electrically. Instead, it comes down to manufacturing, practicality, and a little bit of history. The story behind the color is far more interesting than you might expect. So let's break it all down right here on History of Simple Things. Before printed circuit boards existed, electronic devices were assembled by hand. During the early 20th century, technicians connected individual wires between components, creating what was known as point-to-point wiring. Radios, military equipment, and early computers contained hundreds or even thousands of hand-soldered connections, making them difficult to manufacture and repair. Everything changed after World War II as printed circuit board technology matured. Instead of wiring everything by hand, engineers could print copper pathways directly onto an insulating board. This made electronics smaller, cheaper, more reliable, and much easier to mass produce. As circuit boards became increasingly complex throughout the 1960s and 1970s, manufacturers also needed a way to protect the delicate copper traces from corrosion and accidental damage. That's when the now famous green coating began appearing on nearly every board. One of the biggest misconceptions is that the board itself is green. It isn't. The actual base material of most modern circuit boards is made from layers of fiberglass reinforced with epoxy resin. On top of that sits a thin layer of copper, which forms all the electrical connections. The green color comes from a protective layer called the solder mask. Despite its name, the solder mask doesn't stop electricity. Instead, it covers most of the copper while leaving only tiny openings where electronic components need to be soldered. Without this protective coating, exposed copper would oxidize over time, making it harder to solder and reducing long-term reliability. The solder mask also prevents accidental solder bridges, where molten solder unintentionally connects two neighboring copper traces and causes a short circuit. So when you look at a circuit board, you're mostly seeing the solder mask, not the board itself. If solder masks can be almost any color, why did manufacturers settle on green? The biggest reason is that green turned out to be one of the most practical colors for manufacturing. During the early decades of printed circuit board production, technicians spent hours visually inspecting boards for tiny defects such as scratches, broken traces, dust particles, or manufacturing errors. Green provided excellent contrast against the shiny copper traces and the white markings printed on the board, making these flaws easier to spot. Human eyes are also particularly sensitive to green wavelengths. Our vision can distinguish many subtle shades of green more easily than many other colors, which helps inspectors identify tiny imperfections during long shifts without as much eye fatigue. As electronics factories expanded around the world, this practical advantage helped make green the industry standard. There was another important reason green became dominant. The epoxy materials used to make green solder masks were among the earliest formulations that consistently delivered excellent durability, heat resistance, and chemical stability. Manufacturers refined green solder mask chemistry over decades, making it highly dependable for mass production. Because millions of boards were already being made this way, suppliers optimized their equipment, materials, and production lines around green. As a result, green solder mask became widely available, thoroughly tested, and often the most economical option for large production runs. Even today, many manufacturers still choose green simply because it has a long track record of reliability and remains the default color offered by many fabrication facilities. Can circuit boards be other colors? Absolutely. If you've ever built a custom gaming PC or looked inside high-end electronics, you've probably seen black, blue, red, white, or even purple circuit boards. These colors are created simply by using different pigments in the solder mask. Electrically, they all perform essentially the same job. However, different colors come with small trade-offs. Black boards can make scratches, tiny cracks, and copper traces harder to see during inspection. White boards are excellent for products that use bright LEDs because they reflect light efficiently, but stains from soldering can be more noticeable. Blue and red boards are popular for branding and aesthetics, while matte black has become common in premium consumer electronics because it gives products a sleek appearance. Some manufacturers even choose colors purely to make their products stand out from competitors. Despite all the available options, green continues to dominate many everyday electronics. That's because most products are built for efficiency rather than appearance. Smartphones, routers, televisions, kitchen appliances, printers, and industrial equipment all hide their circuit boards inside protective cases where nobody will ever see them. If the board is going to stay hidden, paying extra for a custom color often provides little benefit. Green remains familiar, dependable, easy to inspect during manufacturing, and readily available across the global electronics industry. For companies producing millions of identical boards each year, sticking with the standard simply makes economic sense. So why are computer circuit boards green? Not because electricity flows better through green boards, and not because the fiberglass underneath is naturally green. The color comes from the solder mask, a protective coating that shields copper traces from corrosion, prevents soldering mistakes, and improves long-term reliability. Green became the standard because it made manufacturing easier, reduced inspection errors, and benefited from decades of material development. While modern technology allows circuit boards to come in almost any color imaginable, green has remained the industry's trusted default. It's one of those details that most people never think about, yet nearly every electronic device around us quietly carries this decades-old engineering tradition inside. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.